Welcome back to the channel Einstein Mechanics. And today we are going to solve some example problems on differentiation. Now let's start with this example. What to be the derivative of cos inverse of x? Okay, with the previous videos that we've been doing, we did talk about the derivatives of trig functions, but not inverse trig functions. But what we have here is an inverse trig function, and we do not know how to go by that. So let's see how we are going to take the derivative of the inverse trig function, which is cos inverse of x. So solution. Okay, let's let y represent the function. So y is cos inverse of x. Okay. So now we have y equals cos inverse of x here. Now what do we do again? We do not know how to differentiate cos inverse of x. We do not know anything about that. So let's find a way to eradicate the cos inverse of x. And by the inverse rule of trig, when you multiply a trig function by its inverse, it will go to 1. So let's take the cosine of both sides of the equation. So we're going to get cos y equals cosine inverse of x like this. Okay. So we are going to get cos y equals x, because cosine of x is going to give us 1. So it will be left with x. So now we do not have any cosine inverse in the question again. We only have cos, which we know how to differentiate. So cos y equals x. But mind you, y has not been expressed in terms of x. That means that this is an implicit differentiation or an implicit equation. So you have to use the idea of implicit differentiation to differentiate this. Okay. Now we have cos y. The derivative of cos y is negative sine y dy over dx, because we took the derivative of y with respect to x. Okay. Now the derivative of x is simply 1. Or in other words, 1 dx over dx. Dx over dx is still 1. Okay. So we have our negative sine y dy over dx equals positive 1. Now let's make dy over dx the subject. We're going to get negative 1 all over sine y. Okay, so that's our final answer. But mind you, we have the expression in terms of y instead of x. So we have to find an expression for y in terms of x. And from here, we know that cos y equals x. So cosine of a certain angle equals x. So we can write, or you can draw a right angle triangle and represent the whole thing on it. So this is a right angle triangle. So here is 90. So here is our y, which is the angle. But mind you, cos y equals x over 1. So this is the same as this, right? And per our SOHCAHTOA, we know that cos is adjacent over hypotenuse. So cos y is going to be cosine of the adjacent over hypotenuse. What is the adjacent of y? The adjacent is the angle on which, the side on which the angle sits. And the angle is sitting on this side. So we are going to have x here, right? Because it's adjacent, which is this side, over hypotenuse, which is the longest side, right? Okay. So we need sine y. We have cos y, so we need sine y. When you get our sine y, everything is now going to be in terms of x. Okay. Now let's look at something here. What is sine y? Sine y will be so opposite over hypotenuse. So this side, which we don't know. Let's say it is a over hypotenuse, which is 1. Okay. We don't know this side, but this is simple trigonometry, Pythagoras theorem. We can say that 1 squared equals x squared plus a squared, right? Okay, so making A the subject from here, we can say A squared is actually equal to 1 squared minus x squared. So A is going to be square root of 1 minus x squared. Okay, so we know our A now, and this is our sine y. So sine y is going to be A, which is square root of 1 minus x squared all over 1, which is the same thing. So now we have sine y in terms of x here. So our derivative of y with respect to x, which was initially negative 1 over sine y, can now be written as derivative of y with respect to x equals negative 1 over the square root of 1 minus x squared. So this is the final answer. Let's move on to the next example. Example 2, d over dx of tan inverse of x. Okay, so you can pause the video and try your hands on this one, just like the first one, the same application. So solution. Let's let y equals tan inverse of x. Okay, so we know that our y equals tan inverse of x. So multiplying through by tan, we're going to get tan y equals x. So this is an implicit. As usual, we take the derivative of tan y. You are going to get sec squared y dy over dx equals 1. Okay, now let's make dy over dx the subject. We are going to get dy over dx equals 1 over sec squared y. Okay, so when we have 1 over sec is the same as cos. So when we have 1 over sec squared y, we are going to get cos squared y. So dy over dx can be also written as cos squared y. Okay, now we have our dy over dx to be cos squared y, but we want everything to be in terms of x. So just like we did for the first one, you draw your right angle triangle. Forgive me if my diagram is misbehaving. Okay, so our angle is here. We are taking it from here. Tan y equals x. But we shouldn't forget that tan y equals x is the same as x over 1. And from SOHCAHTOA, tangent is opposite over adjacent. And the opposite, or the side opposite to y, is what? This side. So here will be the x. And the side adjacent to the angle is where the angle is sitting. So here. Okay, so we need our cos y. Cos y will be ka adjacent 1 over hypotenuse. Let's say here is h, but we don't know h. But from Pythagoras theorem, it's easy. H is going to be square root of n squared plus 1 squared, which is the same as square root of 1 plus x squared. Okay, now we have our h, so let's put it in the cos y. So cos y will be equal to 1 over square root of h, which is 1 plus x squared, right? Okay, now we want cos squared y, not cos y. So let's square everything. So cos squared y will be equal to 1 over square root of 1 plus s squared, all squared. So at the end of the day, our cos squared y is going to be 1 over 1 plus x squared. Okay, now we have our cos squared y, so we simply put it here. So our dy over dx is going to, which is cos squared y, is now going to be dy over dx equals 1 over 1 plus x squared. So that's the final answer. So when you take the derivative of the inverse tan of x, you're going to get 1 over 1 plus x squared. Okay, Let's move on to the next example. So example 3. Find f prime 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 of x if f of x is equal to x to the power 4 sine x. Okay, so this is a higher order derivative, and a question like this, it is actually in the product form, so I recommend using the Leibniz theorem. So let's start. Solution. We have our f of x to be x to the power 4 sine x. So comparing this to f of x equals u v, we can say our u is equal to x to the power 4 and our v is equal to sine x. Okay, now our f prime 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 of x is going to be, okay, so here you need to know how to expand the Pascal's triangle and some little bit of trick. So here what you do, you have our u multiplying v in this direction, so you write your u plus the first derivative of u with respect to x plus the second derivative of u with respect to x plus the third derivative of u with respect to x. Then you start with the v from the right hand side. We started with the u from the left hand side, going this direction. Then you start with the u from here, going this direction. So here we will have our v here, our dv over dx here, our d squared v over dx squared here, and our d cubed v over dx cubed here. So we're writing it well. We are going to have something like this. So f prime prime of x is going to be, we're going to have u d cubed v over dx cubed plus du over dx multiplying d squared v over dx squared plus d squared u over dx squared multiplying dv over dx plus v multiplying the cubed u over dx cubed. Okay, so we have everything here, but we need the coefficient. So we have how many terms here? We have 1, 2, 3. We have 1, 2, 3, 4. We have 4 terms here. So we have to expand the Pascal triangle up to we are going to have the fourth coefficient, or four coefficients. So we have 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. So we have 1, 2, 3, 4 coefficients. So we multiply the first one by the first coefficient. So here will be 1. Here will be 3, the second coefficient, right? Here will be also 3, and here will be 1. So at the end of the day, f prime 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 of x is going to be u d cubed v over ds cubed plus 3 du over du over dx multiplying d squared v over dx squared plus 3 multiplying d squared du over dx squared dv over dx plus v the cubed u over dx cubed. Okay, so this is what we have. So we need the third derivative of v which is equal to x. We need the first derivative of u, and in that order. So we have to differentiate each of these up to the third derivative. So if we have all of them, then we will simply substitute them here, then we are good to go. Okay, so let me clean this and have some space here. So we have our u as x to the power 4 and our v as sine x. Okay, so from here u prime, or du over dx is going to be 4x cubed. The squared u over the x squared is going to be 4 to the 12, so 12x squared, and the cubed u over the x squared is going to be 24x. Okay, so we have our v2 here. So our dv over the x is going to give us, when you differentiate sine x, we get cos x. The squared v over the x squared is going to be, when you differentiate cos, we get negative sine x. The cubed v over the x cubed is going to be, we have our negative here. So when you differentiate sine, you're going to get cos x. Okay. So having this, our f prime prime of x was expanded to be u d cubed v over the x cubed plus 3 multiplying du over the x multiplying the squared v over the x squared plus 3 multiplying the squared u over the x squared multiplying the v over the x plus v the cubed u over the x cubed. So we just do our substitution and we are good to go. So f prime prime of x is going to be, we have our u there. Our u is what? X to the power 4. So x to the power 4 multiplying the cubed v over the x cubed. The cubed v over the x cubed is negative cos x here. So multiplying negative cos x plus 3 multiplying du over the x. Here our du over the x is 4x cubed. So 4x cubed multiplying the squared v over the x squared, which is negative sine x plus 3 multiplying the squared u over the x squared. The squared u over the x squared is 12x squared. 12x squared multiplying the dv over the x. Our dv over the x is cos x plus our v, which is sine x, multiplying the cubed u over the x cubed, which is 24x here. So 24x. Okay. So by expanding, we are going to get negative x to the power 4 cos x plus 12x cubed. Sorry, minus rather, because you have negative sign here. We're going to get minus 12x cubed sine x plus 36x squared cos x plus 24 sine x. So we can rewrite this and bring the positive ones first to have, let's say, 24 sine x plus 36x squared cos x minus x to the power 4 cos x minus 12x cubed sine x. So this becomes our final answer. So when we take the third derivative of x to the power 4 sine x, this is what you are going to get. Okay. Now, what about taking the fourth derivative? When we take the fourth derivative of this same function, what are you going to get? Okay. So this one, I will not solve it. I will just do the explanation and you try your hands on it. Okay. So we want the fourth derivative. So our Pascal's expansion is going to be 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. So we are going to use this as our what? As our coefficient. So the coefficient is going to be 1 4 6 4 1. So let me write it here. 1 4 6 4 1. All right. Now our f to the our fourth derivative of x is going to be, we have our u here. So we will write the u up to the fourth derivative. So u will be here. We have our du plus du over dx plus d squared u over dx squared plus d cubed u over ds cubed plus d to the power 4 u over dx to the power 4. Then we start with the v from here. So you multiply v dv over dx d squared v over dx squared d cubed v over ds cubed. Then our u will multiply by d to the power 4 v over dx to the power 4. Then we write it for you. Okay, so we're going to get u d to the power 4 v over dx to the power 4 plus du over dx multiplying d cubed v over dx cubed plus d squared u over ds squared multiplying d squared v over ds squared plus d cubed u over ds cubed multiplying dv over dx plus v multiplying d to the power 4 u all over dx to the power 4. Okay, so we then add our coefficients. This is 1 4 6 4 1. So here will be 1 4, here will be 6, here is going to be 4, and here is 1. Okay, so at the end of the day, f prime or fiv of x is going to be u e to the power 4 v over dx to the power 4 plus 4 du over dx multiplying the cubed v over dx cubed plus 6 d squared u over dx squared multiplying the squared v over dx squared plus 4 multiplying the cubed u over dx cubed multiplying the v over dx plus v to the power 4 u over dx to the power 4. Okay, so this is the expansion that you are going to get when you are finding the fourth derivative of that x to the power 4 sin x. So you will need before d to the power 4, you are the fourth derivative of v with respect to x. So you need all these derivatives, you just combine them, and when you are done multiplying and doing everything, the final answer is going to be in this form. You have 24 sin x plus 96 cos x minus 72 x squared sin x minus 16x cubed cos x plus x to the power 4 sin x. So when you do the derivation and multiply everything, this is the answer that you have to get. Okay, let's move on to the last example. Okay, so this is quite simple. All that you need to do is to know how to do the Pascal's triangle expansion and all that. Okay, the next example is find the point of inflection of the function x to the power 4 minus 3x squared. So this is f of x. x to the power 4 minus 3x squared. We are supposed to find the inflection point. And what we know about inflection point is that at inflection point, the second derivative of the function is supposed to be 0. So f prime prime of x is supposed to be 0 at inflection point. Okay, so let's see if you are going to get the second derivative. So f prime of x is going to be 4x cubed minus 6x. F prime prime of x is going to be 12x squared minus 6. So at inflection point, we are saying that f prime prime of x should be 0. So 12x squared minus 6 should be 0. So 12x squared is going to be 6. Dividing both sides by 12, x squared is going to be half. So x will be the square root of half plus or minus. So x, so the point of inflection is either plus square root of half and minus square root of half. So that is that. So thank you for watching this video. Thank you for giving us your time, making time for us, watching the video, and stay tuned. You will be updated if anything new pops up. Thank you for watching Einstein Mechanics channel. Bye bye.